students. So in this lecture, we will be uh, learning about the chain drive and its power rating. So the power rating of roller chains is actually given by this relation kilowatt. Power is in kilowatt. Kilowatt is power is in kilowatt. Just power. So power equal to P1 into V by 1000. Now here P1 is actually the tight side tension or the maximum tension in the chain. The allowable tension, actually this is the maximum tension of the chain. Simple. Because you know the chain also will have tight sides like that, tight side tension. Okay, multiplied by the linear velocity. Okay. This is actually average velocity of the chain. So the linear velocity of the chain must be known. Then you multiply it with your allowable tension. That is the maximum, the maximum, maximum force, or you can say that this is the right side tension multiplied by the velocity. Divided by 1000 gives the value in kilowatt. Now the standard dimensions and breaking loads of roller chains are given in data table. Now here standard dimensions are the chain dimensions. Okay, and I mean, like suppose length, then the pitches, etc. Designation. These things are available. I mean, as part execution of the change, these things are available in your data table, and something called breaking load, okay, or breaking force in roller chains. So this is the force that will cause the breaking of your chains, or is the, we can say one should not cross the limit of breaking force, okay, or breaking load, let me call it. So breaking loads are there in the data book. So for let's say for a chain of 08P, okay, or 08A, or whatever, that resignation chain, we will have the breaking load from data book, and we have a limit now, so that we cannot reach, or we cannot just cross the value of breaking load. Okay, then only your chain design will be safe. Next, we have a factor of safety of roller chain can be chosen from this. So here, factor of safety is nothing but the load that causes the failure divided by the allowable load. So this breaking load is what we should not reach. Okay, or that kind of load is that kind of load is there in your data book. So that value of breaking load should not be reached. Okay, in any case, so that your chain remains, your chain should not, I mean, chain will not break. Okay, chain remains within limit. For that purpose, we should not cross the breaking load of the chain. Okay, so divided by allowable tension is the maximum value of the force, or that is called, let's say that is a tight side tension. So in order to save the chain from breaking, the tight side tension should not reach the value of breaking point. And for that reason, we need to employ a factor. Now the power rating can be determined from this relation. So power rating, power in kilowatt rating. So for any chain, the power ratings are available in your data book, and they can be calculated from this also. Power to be transmitted, this is what we have found from this formula, multiplied by a factor Ks. We'll learn about this factor now. Divided by two more factors, K1 and K2. Now Ks is the service factor, as we have learned this from your belt drive. Okay, from the beginning, from the belt drive, we have been using this power service factor. So depending upon what type of service, what type of loads are there, what type of driven and driving units are there, okay, how many hours of load are there, based on all these we have a service vector, and that service vector to be multiplied to power transmitted here, this one, is multiplied by the service vector divided by two more factors. Now these two factors, K1 is called multiple strand factor divided by one more vector. This k1 and k2 both are multiplied. Then we divide the whole by so k2 is tooth correction factor. Now, what is multiple strand? Now, yesterday, the video that I posted. So there, I have told you about this multiple strand. So strand is a you see like it is the you can say if you have only one chain, it is single strand or simplex we call. If you connect two chains together, I have shown you that one image of that. So two chain when we extend the rollers and we connect more links to give it a shape of connection of two chains together and they will transmit the torque together as a whole. That is duplex chain. Similarly, if you have three of them, duplex. So more than one, that is multiple. Okay. So more than one type of strand if it is present. Those are called strands. Okay. So more than one strand, whenever it is present, then we'll have to multiply a factor. There is multiple strand factor. For single strand, this factor is 1. For more than one strand, suppose 2 strands, 3 strands, 4 strands are there, then we'll have a value of this multiple strand factor. This value is again available in data book. Next, K2, tooth correction factor. Now here one thing, the power ratings, these power ratings are actually available in data book and they have been calculated based on uh, they have been calculated by assuming that the sprocket, this driving sprocket, this is the sprocket, right? So the driving sprocket has 17 number of bits. It was assumed. Okay. That means Z1 is 17. By taking Z1 as 17, the power ratings are calculated and that they are available in the book. Right. But what if the number of teeth in this sprocket is more than 17 or less than 17? Okay. Will you use the same power rating? In that case, we can take the table which is derived where the values are available for 17 number of teeth, but with modifications. So suppose there are 17 number of teeth in a sprocket, and we have got a power rating table for 17 number of teeth sprocket. So we can use it if the number of teeth are 17. But if the number of teeth is 18, 19, okay, or 20 something, which is more than 17, which is not 17 exactly, then these values that is available in the data book, we are not using them directly, okay, as a power rating. We have to modify this power rating. So what we do to modify, we have to take another factor, okay. So that factor, 1 by that factor is multiplied to this whole thing. That means we divide the whole thing by K2. K2 is the factor. So K2 is called tooth correction factor. Whenever there is, you see that the number of teeth is not 17, okay, it's more or less than 17. You see, the standard power ratings are total based on 17 number of teeth on direct sprocket. Okay, the sprocket should have the odd number of teeth so that the even number of chain links can fit to these things. Okay, that's why odd numbers, generally odd numbers. Okay, so now you see the based on 17 number of teeth, the power ratings are taken. If we have more or less than 17 number of teeth in the sprocket, driving sprocket here, okay, I'm talking about the driving now. Okay, so if it is not 17, then we will have a correction factor, and that is called tooth correction factor. Okay. Then multiple strand factor I already told you. For simple or simplex chain, okay, see, we have multiple strand factor as one. If the chains are duplex, triplex, or more something, a multiple strand factor accounts for a change. Okay. So the values, whatever are written in your data book, are for simplex chain. But if we need the value for duplex, triplex chains, we have to use this multiple strand factor, and these values are now of multiple strand factor, duplex factor are available in data. Even this travel factor is also available in data. Okay, now how to design? Let's go to some the rules of designing a chain diagram. So here two important rules you need to follow. So the number of pitches or number of links should be even. This is what I do. So this you must keep in your mind. So make the pitch value even, okay, or the number of links that you use. That I told you why do we need to use even number of links, because these are two rollers. If we connect one link here, we cannot leave the other part. So we'll have to connect another link. That's why it makes two. We introduce one more roller, it will make four links. Okay. So or every time we have both two links both sides. So links or pitches. So pitch, this is the pitch, right? This is the pitch. This is not a chain. If we have only two rollers, even three or four rollers will not have a chain. We'll have to completely enclose the whole thing. Then only it will be a chain. So the pitch is also not odd. Pitch is also even. Okay. So then, then total number of teeth in the driving socket should be odd, because then only your even number of uh, links will fit. See, from here to here, if you count two rollers, okay, this is only one teeth that is going in between. So two more rollers, one teeth is going back in between. So like that. So here one, two links, three, four links, six links, 8 links, 10 links, 12 links. So here the chain comes out. So here you can count 1, 2, 3, 4, 5, 6, 7. So this will get engaged with them. So here seven, see, odd number of teeth will engage with even number of links. Okay, so it's like that. So here this also you need to keep in mind. So in case you cannot just your calculation gives you some value of link which is odd, and I told you how to make it even using offset link. Okay, that was given in the previous lecture. So now the region here, please go through that. Okay, please read it. So why it happens, everything is clearly written. Okay, to save time, I'm just skipping this one. Okay, now here we have a short numerator. Let's go to the numerator. By the way, I cannot show you the data book here. In the data book, when you go to chain drive, okay, then you'll see have some values of by breaking load from bottom. Okay, so here for a single strand chain 12p, I'll give you a page number. So from the single strand chain number 12p, so chain designation is 12p. The driving sprocket has 17 teeth and rotates at 1000 rpm. What is the factor of safety used for standard power rating, neglecting centrifugal forces? So here you see driving sprocket has 17 teeth. This given, but this is there's one. So then and driving sprocket speed is also given. That is 1000. Okay. Chain is 12. What will be the pitch value of this? I told you whatever value we have in the resignation divided by 16 to get the pitch in inches. So 12 by 16. So here pitch of the chain you can get it also from data book, or if you calculate it 12 by 16, okay, that will be in inches. So convert it to millimeter. So if you convert it directly 12 by 16 and convert directly to mm from inches, the conversion factor is there. I don't remember it. So 23 or something. You multiply with that, so you will get this value. Or otherwise, if you can use the data book, and data book in the data book it is directly written 19.05. Okay. Then the velocity is z1 p n1 divided by 60 to 10 over 3. So z1, this relation we already know. Okay, and from this relation z1 this is 17, e is 19.05, n1 is 1000 divided by 60,000 which is equal to 5.4 meter per second. Is the velocity. Then from the above, power rating 4000 rpm and 12 beat chain is this one. This part is actually from the data book you have to get. but in most of the cases, it's given in the question itself. Okay, so even if you don't find a power rating, don't worry, it will be given in the question. So power rating of the chain is the along with the question. Next, since you know the power rating, so you have the relation here. No? This is the power rating. Power rating equal to transmitted power into Ks by K1 into K2. So here, oh, one more thing. Sorry, we have not used the power rating by the way. So this is, oh yeah, just a minute. We have used the this relation only. Okay, that is not shown there. So power rating is 15 point something in the question. Calculation that calculation is before this we have done. The power rating is 15. Okay, 15 point something. So we need to find out this power to be transmitted. So K1 is multiple strand factor. That will be 1 because it's a single strand or simplex strand. Say only one strand is there. Next, it has 17 teeth. So the K2 value is also 1. So this is 1, this is 1. And Ks, there is no information about it. Okay, that what is the service and all this, what it is driving and driven. So we can assume K as 1 because the information is not sufficient here. Okay. For it, we have assumed that K is equal to 1. So power to be transmitted is equal to power rating. That's why this is power to be transmitted only kilowatt because we have used the previous expression here. This is power to be transmitted equal to P1 V by 1000. So power rating is equal to power to be transmitted. So we have got that as 15 point something given in the 15.6. So put it here. This is in kilowatt. This is P1 equal to P1 into 5.4. Sorry. So this is P1 into 5.4 divided by 1000. Okay. So from here P1 equal to, if we calculate, if my calculations are correct, is 2898.15. So we have got the allowable value of the force or right side tension. Right side tension is, so one thing, what else do you need to find the factor of safety? You need this breaking load. Okay? Because you have got allowable tension, to find out Fs, you need the breaking load. And the breaking load can be taken from data book. Okay, you'll directly get in the table itself. Okay, so in the data book, that the breaking load is 29500 Newton. One catch is there in in that data book that you you are given with, see there's a last, in the last column, this breaking load. Let me short, PR means breaking load, not PR. So this is given in kg. Okay, remember this. This part is given in kg in your data. So the value of 12 beat change will be given like this, 2950, okay, kg, right? But we need the breaking load in Newton. Remember this. This is in Newton. Huh? So 2950 kg. If you multiply with 9.81, you will get the value in Newton. But to make it approximate, we multiply with 10. We take 9.8 as 10. So if I multiply 10 as 10 is actually 10 meter per second square. Okay. If you multiply with this, your breaking load becomes 29500. Okay. So 250 into 10, that is 250 Newton. So if you because now your units are consistent, so breaking load divided by P1 gives you factor of safety. Okay. So this is how we find out the factor of safety. So this ends our lecture here. We'll continue this in the next class.